Hello. I said yesterday I was going to talk a bit about y equals 1 over x and how it vanishes off without actually it gets closer and closer to the axes but actually never gets there. So I've written this thing where x is 1, 2, 3, 4, etc. and just carries on getting bigger and bigger. And these values, these are the fractions 1 over. But it's a bit easier to demonstrate what's happening if I don't choose these values for x, but choose these ones, these doubles. And what I'm going to do is I'm not going to plot the negative side. I'm just going to consider this positive quadrant. And so this is where I'm going to draw it, down here. And by the way, in all these videos, this horizontal line looks as if it's sloping up to the right. It's just the way the camera is doing this. It's a bit annoying, but it's some sort of it's the lens, the way the lens works. So I'll put these values of, let's see if I can see how far we can go to the right here. So this is 1, x equals 1 equals 2. I've chosen quite a big scale because I'm going to have to, no, I'm wrong there. Well, I'm going to need to fit a whole load in there with it. These are the fractions. All of those up there are going to be the fractions. Well, yeah. Anyway, we'll see. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we've got to this one. We're not able to get any further than that. But I also want to fit in. I started here at 1, but I also want to fit in here a half, a quarter, x equals a quarter, x equals a half, x equals a quarter, x equals 1 over 8, x equals 1 over 16, x equals 1 over 32. Right? I hope you can see that you actually carry on doing this, you actually never get to 0. Every time you divide, you don't get to 0. Every time you divide by 2. So anyway, if these are the values of x, y equals 1 over x is equal to 32, 16, 8, 4, 2. So these values of x here are all crammed into this space. So let's put a scale up here. what's that? 1, 2, 3, 4, 5, 6. Let's just get rid of that. 6, 7, 8, 9. Right. So this is x, and this is y equals 1 over x. I'm going to start with this x equals 1. When x equals 1, y equals 1. When x equals 2, y is a half. When x equals 4, now what am I doing? That's a stupid thing. When x equals 2, y equals a half. When x equals 4, when x equals 4, y equals a quarter. When x equals 8, y equals an eighth. So we say it's there. And when it's 16, I'm not sure what 16 was now. It's very close to the x-axis. And going the other way, when x equals a half, y equals 2. And when y equals 4, no sorry, when x equals a quarter, yeah, when x equals a quarter, y equals 4. 1, 2, 3, 4. And when it's x equals 8, 1/8 I mean, when x equals 1/8, y equals 8. I wonder if I can try and draw this. There you go. I don't know whether there's very much more to say about that. Once you get it, you get it. Well, I could say that this point must be, when x is 3, y must equal a third. Yeah. Now here's the quarter, which is a little bit less. And a fifth. And a sixth. Etc.